Our topic here is to talk about Intuiflow's scheduling and execution functionality. And we held a demand-driven operating model introduction session yesterday. And if you missed that one, I'd encourage you to take time to access that once we post the content. We borrowed the DDOM presentation from the Demand-Driven Institute, which was quite helpful. And I think it's very important to get that full context, if you will, before you start to drive too far down into the scheduling and execution functionality. We're going to touch on some of those concepts in the presentation today, but I also want to kind of illustrate some of the other foundational elements of the software in Intuiflow scheduling and execution so you can kind of understand. They're largely built on the concepts borrowed from theory of constraints called drum buffer rope. Anybody who read the book The Goal would be familiar with those ideas that were shared by Dr. Goldratt. The predecessor of Intuiflow scheduling and execution was a product we call DBR+, which is fairly widely adopted by clients. Probably about 40% of our install base are using the software, and we're expecting that number or that share to grow as we go forward, primarily because the solution until the new Intuiflow release was not yet in the cloud environment. And so by getting it into the cloud, packaging into the Intuiflow product, we're in a much more modern and scalable position to start leveraging that solution on a wider basis going forward. So let's go ahead and kind of dive in here. I want to make sure that we're really focusing on kind of where this fits in the landscape of a demand-driven adaptive enterprise. So we're going to go back over some of those concepts that we shared in the DDOM presentation yesterday, and hopefully you'll start to be able to put the pieces together as we go forward. So on the left side, and this is again borrowing content from the Demand-Driven Institute, the goal that we're after here is to improve the management of our supply chains by pacing to the most accurate signal we're going to find, which is the actual demand in the market. Not a forecast or an estimate of what the demand will be, but what actual orders from our real live customers have come in. If we pace our demand-driven operating model, which has two primary components, materials planning and production scheduling and execution, if we then manage that operating model in an effective way, making it able to pace to the actual demand, we're going to be adopting a cleaner signal. We're going to get a lot of results and benefits from that. So it's about putting that operating model together and really getting it to work in a fashion that's manageable, providing the right results, improving our on-time order fill rates, as well as managing our inventories in a proper way. And one of the key things in the DDOM model is that there is an effective handshake between the materials planning signal, which are really the most direct recognition of the market signal that we're trying to chase, and our production environment. Because DDMRP as a methodology of its own is really not aware of what capacity limitations or other production side limitations you may have. So in essence, we want to create that handshake so that things like due dates for orders that we're generating for manufactured parts can be tested for available capacity. In other words, are the lead times that we're using really in line with what our production environment is? At the same time, the production promise dates that we generate through our scheduling on the DDOM side can come back and inform the execution alerts that are on the material side of the house. So we're really after getting these synergies, and that's why I'm so excited about having the scheduling platform now in Intuiflow, because it opens up a lot of additional functionality for our clients to take advantage of and bringing those two sides of their operating model together. So as you would have learned if you were in the session yesterday, we have 3 different buffering techniques or strategies that we can follow. On the materials planning side, it's about stock buffers using DDMRP logic. Stock buffers can compress our lead times. They're going to decouple variation and improve our ability to have a more stable operating environment. And as well, the buffer status indicates priority, relative priority. And this is very, very important in enabling us from a planning and scheduling standpoint to know what is really the most critical to focus on. The depth of buffer penetration, therefore, gives us a better signal as to which items should get highest priority in terms of production capacity that we've got available. On the scheduling and execution side, we introduced 2 types of buffers now. A time buffer, which is put in front of our drum resources, and we'll talk about those here in a few minutes, to protect the pace of that drum. In other words, if the drum is the constraining resource in our production flow, any time lost on the drum is lost to the entire system. So we want to be very, very careful to make sure that we've always got work available for that drum resource to be performing against. And therefore, we put a time buffer in front of that drum to help us ensure that happens, and to also protect from upstream variability in the routing that may occur, which could impact our drum schedule. As well, we introduced the idea in the DDOM session around capacity buffers. And this is the idea that we're going to have enough sprint capacity at our various resource stages that they're not going to limit the output of the routing getting to the drum and impairing its ability to produce to its maximum capacity. So we'll go into this in a little bit more detail, but those are the two new types of buffers that we're introducing when we get into the demand-driven operating model. If we use these wisely, we get further stability, we improve our on-time in full order fill rates, we stabilize plant operations, and we actually have a much more healthy environment to be working from. As well, the promise dates that we generate come back and create signals on the materials planning side so that we can properly manage those and really balance the materials and the production sides of the house in an effective manner. All right. So I mentioned that Intuiflow scheduling and execution was previously known by the name of DBR Plus, or Drum Buffer Rope Plus. So a lot of the concepts that we're going to talk about here really echo from the true TOC-based concepts. The difference is that I think what Chad and Carol have done at the Demand Driven Institute with describing the DDOM is they've done a more complete job of really relating how of these different functionalities work together and give us, a better way of operating our business on a day-to-day basis. So, our Intuiflow scheduling and execution platform is the first one that was certified as compliant with DDOM. This goes back some number of years. That's really the DBR Plus heritage. It's a constraint-based scheduling solution. So it uses the concept of identifying our bottlenecks or our constraints and really pacing activity within the plant based on what those constraints can absorb. As you'll see when we get into the demo here in a couple minutes, we can have multiple constraints in an environment. There was some thought in the early days of TOC around simplified DBR where you could really only have one, but in today's manufacturing environments, we see more and more often that given the way the plants are laid out and value stream orientations that they've got, that there can actually be more than one constraint in a given environment. And so we've got the functionality to support that. By doing a better job of managing those constraints in terms of our scheduling and managing the workflow across those resources, we improve our due date performance, stabilize operations, and we create, probably more important than anything else, visibility. So people can make much more informed decisions about how to intervene if and when they have issues. As we'll talk about types of variation that impact our systems, but those are certainly a reality that we have to make sure that we're prepared to work around. And it's really kind of that second part of the puzzle here in terms of enabling a full DDOM model. So drums, they're strategic operations. They have limited resources. They're going to pace the activity through a plant. It can only go, the output of the plant is going to be dictated by our drum resources, because if they're the rate limiter, they're going to determine the output of the entire system. And that's really, really important to keep that in mind, because if we manage that well, now we start to gain much better control of our environment. There are times when the drum isn't necessarily the slowest. It may be the resource in the flow that has the greatest variability, and we talked about that in the presentation as well. And the reason you might think, well, why would I pick the one that has the most variability? Well, if I don't manage that variation well, then I'm going to be impacting all of the other resources in the routing that utilize that highly variable resource in question. And so again, it's about focusing, gaining control of that, getting its variation down, and putting it into a better situation. So, and we'll talk about this when we get in a little bit of applying the DDOM concept. Oftentimes that control point that we're really looking for, that pace setter resource, may be something that isn't technically the constraint, but is ideally positioned to be the the pace setter resource in our scheduling and our operations. So we'll talk a little bit more about that when we get into that. The buffer, again, is that pocket of time, that amount of time that we put in the routing to ensure that the work order arrives at the drum resource on a timely basis. We don't want it to come in too early because then we've got too much work in process stacked up in front of the drum. We don't want it coming too late because now we've risked the ability for the drum to achieve the maximum output or throughput that it can generate. And clearly the reason we have buffers there is to protect against variation, just like how DDMRP buffers are there to dampen variation from cascading and help mitigate the bullwhip effect and other factors like that. We also need to manage in a similar fashion within our operating environment. If we don't use or manage variation wisely, then we're going to be in a situation where we're going to be constantly firefighting in our production environment, dealing with all sorts of issues. We're going to be wasting time on resources that we need to utilize, and it's really not a healthy environment on hand. So, and obviously we don't want to help accumulate variation because that's going to impact us severely. So we want to make sure that we're providing measures within our operating model to really bring these under control. And variation can come from a variety of different dimensions. It can be fluctuations in the rate of actual demand. It can be fluctuations in the variance that comes in through our supply, either from external suppliers coming into the system and or supply variation within the workflow of our own manufacturing environment. We all know Murphy's Law, if things can go wrong, they will. So that often happens. You might have a machine breakdown. You may have machine operators that are not available because they just got tested positive for COVID and they're not allowed in the building. You name it, there's all sorts of that type of variation out there. And so we're better off positioning and planning to address that ahead of time, because if we plan otherwise, if we plan assuming there isn't going to be variation, we're going to always be in a difficult situation because things will not go according to the schedules that we arrive if we don't do that. We can also generate some of our own problems, and this can be batching strategies, over or under reactions to whatever is happening in the plant. So we want to really be mindful of this as we're looking at implementing our operating model, because the better we control these, the better situation we're going to be in. When we go into an implementation, we do quite a bit of analysis. This is a process flow mapping tool that we use on our implementations to help us see kind of the way the routings work and where the work orders transpire. Large, heavy lines like these here indicate that that's where the bulk of the activity is flowing through these few resources. You can see some other strong legs, but it gives you a very good illustration of where the work activities flow within a given plant. And we can do this using a variety of different process flow mapping technologies that are out there. Very, very helpful part in getting the group doing the implementation, both on the client side and on our team side, to understand here's kind of the picture that we're dealing with, and how do we really help apply DDOM concepts into that environment. So this is kind of borrowed from the charts yesterday. You can see we've got this idea of control points. These control entry and exit within our operating environment. So you can see we've got stock buffers here, which are protecting against supplier variation, and a control point at the beginning of each leg of these routings, because that's going to be how we manage the release of work out onto the floor. In a DDOM environment, you want to practice a policy of kind of choke and release, meaning we don't want to put more material out on the floor. And the reason is that things may change. So if we started ramping up and loading, work for things that aren't due for weeks down the road, we're just creating a lot of havoc for ourselves, because it's going to limit our ability to be agile and nimble, to dealing with whatever changes happen in the market. And again, that goes back to this idea of waiting as long as possible before we take actions. The drum resource in this case happens to also be a point of convergence, where these two process steps, or legs of the routing come together and give us the ability to perform at this level. We really want to make sure that this happens in a good way. And if we're not protecting that drum with time, then the likelihood of that both of these legs are coming in a synchronous fashion is going to be not well managed. And then obviously at the tail end of the process, we want to protect our ability to fill our orders on time. So we may have control points there if it's a make to order environment, and we may actually put a time buffer in that fashion, again, for make to order items. Or if we're using stock buffers, then obviously we want to ensure that we're replenishing that buffer on a timely basis to make sure it is continually holding constant availability of material to be able to satisfy the demands that come in. Whether it's make to order or make to stock, we're going to have, a better environment if we properly deploy the right types of buffers into that environment. Our drum resources are going to be finitely scheduled. That's how they become the pace setter. And obviously we have to understand that as a constraint, we can't overload them because we're just going to be generating unrealistic promise dates based on the schedule. And we'll show you this in the software here in a minute, where we're going to look at the resource load graphs. And obviously, as we go out in time, we start to see our capable to promise kind of window open up, because now we've got capacity on that drum resource opening up, in the second week of the schedule here. And that's going to give us some opportunities to quote lead times to clients if they're in a make to order environment. It'll give us an understanding of where we're at in terms of the loading on those critical resources. The rope part of the drum buffer rope application concept is the idea of signaling the material release into the plant on a well thought out manner. So the pre-drum rope, and we'll talk about this in a minute as well, is going to reflect the amount of time from when that order is released, the material is first put out onto the floor, to when it should arrive at the time buffer in front of the drum. And if we've properly set up our routings correctly and our setup times and movement times, then we're going to have high confidence that we'll be able to execute against that schedule and get the right result in terms of schedule adherence, keeping the drum saturated with work, and obviously then making our downstream promise dates on a reliable basis. If we put too much whip out onto the floor, it's going to create congestion. It's going to incent people to start working on it, which may or may not be what we'd like to do. Because obviously, if those activities are for events well out into the future, there's a likelihood that those are going to change, and we're going to actually encumber ourselves with more kind of whip and other commitments that have already been made, reducing our level of flexibility and agility in the market. So the ropes, again, are that time period from when it should arrive at the drum buffer to, and when it should be released to get to the buffer on time. And you'll see that in the software and conceptually, there's many different ropes that we can consider, and they just simply play a role in the orchestration of the workload that's going to be delivered out to the floor. So here's kind of a very simplistic example. We've got a few routing steps, then a time buffer in front of the drum resource, after which the material goes to an outside agency, perhaps a plating operation or some type of finishing operation. We may be buffering in front of when it's due to be performed at that outsourcer, or we may elect to put that time buffer before it re-enters our production flow at resource E and then downwards from there. Obviously here we've got a make to order environment because we've got a time buffer after the last step in our production process before it goes to the customer. And that again is going to be there to protect our ability to make our schedule dates. You can see now the drum is going to have a schedule, and the work order will, go across a variety of different steps in the routing, getting to the drum at a certain point in time and making sure that we're adherent to that. The resource load graph is going to show us the loading on that resource out in time. It's also going to show us that workload of which is already released and progressing through the plan. And again, that visibility is very, very helpful. This looks at the other ropes that we have. There's a total rope concept from when we release to when it should be available to ship. There's the pre-drum rope, which is the one we're really most concerned with. Typically, post-drum rope then obviously tells us how much time do we have between when it exits the drum and when it should arrive at the time buffer for shipping out to the customer. So you'll see these are illustrated in the software, but wanted to make sure we kind of grounded what those concepts are about. Now, time buffers, just like we have in DDMRP, the idea of over top of green and the red zone and the like, we have a similar kind of construct in the time buffers, because obviously, if things are coming into the drum too early, we don't want that to happen. That could be because our run rates in our routing are too conservative, meaning they are too easy to achieve. And by doing that, now material is going to show up earlier than we expected. That's not good for us. So we want to capture those reason codes, for example. If it comes in the green or yellow, that's great. It's coming in appropriately protecting the drum resource. If it's coming in late or, in the red priority or late, then obviously we're in a situation where we were highly at risk of impacting the drum schedule and the drum's throughput. And so we want to capture reason codes around these events because those are going to help us from a standpoint of ongoing improvement. Could be that the routing assumptions were too optimistic. It could be that there was a breakdown on a machine upstream of that work order getting to the drum. So there can be a whole number of factors that affect that. And obviously what we're trying to do is get data flowing that we can now, through process of ongoing improvement, do a better job of tuning our model and making it reflect our production environment, as well as implementing continuous improvement actions that will improve the environment overall going forward. So when we model, we have to understand certain of the concepts. One of the most critical is around finite capacity scheduling. The modeling aspect is about transferring our knowledge and understanding of our actual production environment into the software so that the software can actually reflect that. We'll get into the scheduling and execution elements once we get over into the software, but those are all part of the implementation responsibilities or implementation path that we're going to be following as we go through. So I think this is going to be pretty basic for most people, but I just want to use this because it'll illustrate a little bit about how the scheduling engine in our Intuiflow system is going to function. If you took all of the orders as they were asked for from promise dates from clients, you would see kind of this hills and valleys kind of a view when you look at it around that one constraint resource. Some periods where the demand and the requirements for that are well above its capacity, other times where it is below the capacity and unable to really saturate the drum resource. When we go to apply finite scheduling, what we're trying to do then is trim these off because we know we've only got so many hours a day on that drum resource. So if we're planning workload that's beyond that, it's going to have to go somewhere because, especially if we're running 24/7, there is no other alternative but to move it either earlier or later to really balance out our schedule to what the real capabilities are. Some people will plan capacity. They'll actually assume the number of hours that they have operating on the floor in setting up the standards in the environment. And those are all configuration options. Therefore, by doing that, they're actually giving themselves a little bit of wiggle room in case during the course of the day, they run into some issues or, setup items like routing times and run rates and the like that are not going to be effective for them. But what is happening is that we're going to start moving things earlier or later. The idea being that if we can't schedule it on time, then we have to move it one way or the other, to balance things out. And so we're going to schedule earlier if we can't be on time, and then the default will be if we can't make it on time or earlier, we're going to move it late. And so that's kind of the triaging that's going on in the scheduling engine when we're doing finite scheduling. But what we want to do is be within the capacity that we've got. We want to have prioritized in the best manner possible because that's going to give us our best due date performance. So we're going to go over to the software now and take a look at the modeling environment and as well the software from the standpoint of the scheduling side. Just want to be conscious of time here to make sure that we're going to be able to get through a quick demo for you here. So with that, I'm going to move over to the scheduling software. And we're going to go to Intuiflow. Hopefully you're all able to see that. This is the home screen, and this is our front dashboard that shows you kind of all the DDMRP priorities over here. What you see on the right side is kind of the elements that relate to scheduling and execution. You've got some quick links to the scheduler, the buffer board, and other elements like that. You've got some status information around the work orders that are in the environment, all kind of there for you on the home page. But when we implement, one of the key things we have to do is we've got to align our resources and our definitions into the environment. So we have a resource editor function. And in here, we are able to identify all of the resources in the plant. When we think of that, oftentimes, obviously, we're thinking about the machinery and the equipment that we have in the plant, but this can also include outside vendor services. It can include our workforce capacity, our labor capacity within the environment. And so what we're going to create is a way to represent that in the software. So let's talk about resource C1 here. We have the option of creating this resource in the system as either a constraint, a resource, or a buffered resource. A constraint means it's going to be finitely scheduled. A resource would be infinitely scheduled. It's assumed to have sprint capacity. And then a buffered resource would be a resource that is going to be assumed to have infinite capacity, but for various reasons, we may put some time in front of its step in the routing to just give ourselves some further protection. So this is where we're going to declare all of the different resources, and you can do this manually in the system, or you can also upload the data directly. And if you've got lots and lots of resources, it may be a little more beneficial to do it in that fashion. You can have an unlimited number of a given resource. You can set default setup and other time dimensions here. You can create a crew size. You can create an efficiency metric. Let's say the machine is rated for 1,000 units per hour, but let's say you want to hedge on that, so you're going to assume it's going to be running at 80%. You might do that to build in a little bit of protection in your environment. Those are there. My advice has been put in your rated efficiencies from the machinery itself, and then really manage that dimension in your run rates. You don't want to have too many configurations options out there, because you want to have a good tactile sense or grip on the way the system's going to be working. So we're going to define all of our resources in the environment in that fashion. We also have the ability to then set calendars for our resources, because what we're really managing is time availability of the resources. So many plants will have certain parts of the plant that may be running, say, 24/5. Other parts of the plant are only running a 2-shift schedule. Now, we want to reflect all of those resources relative to the base schedules that they've got, and also provide the ability to create overrides and calendar exceptions and other factors, so that it really reflects what our operating footprint is going to be. This is really important to get those calendar definitions and shift definitions into the system, because ultimately we want a well-defined understanding of the time that we have available in a production environment for all the different resources that we're going to be working with. Once we've done that and we've got our calendar set up, we can start to look at, okay, how do we look from a scheduling standpoint? Actually, there's one other one I wanted to show you, which is this concept of the buffer families. And these are there because we've got different types of routings. So much the way we assign parts in DDMRP to given buffer profiles, we can have routings that have different assumptions in terms of how much buffer time do we need in front of the drum resource in that routing to protect it. If we have heavily complex routings, we may want to have much larger, like here we've got a 9-hour time buffer in front of the drum. And in other cases, we're going to have much lower elements. And we use this as a way so that you don't have to manually configure every routing with a unique set of assumptions around that. And it's quite a handy way of creating those time buffers in a fashion that is much more in line with what you're trying to do operationally. Now, having done that, we can run our schedule. And we're going to go over and take a look at the scheduler here. So you can see a whole number of different elements in the display. We've got the planned release date. You can see we are sequenced here based on the planned release date or current going then further out in time. You can see the end request date for the various work orders, the promise date, whether we're on time or late. You can see a priority definition, and we're going to come back to this in a little bit after we run the scheduling and execution demo, and we'll show you how we can adjust that given some other settings that we've got in the system. You can see a handful of the work orders have already been released and are on their way out into the plan. We don't advocate, releasing too far out in time, so we can go ahead and let's say we want to release, there's a few more orders here that were scheduled to be released here on the 6th. So we're going to go ahead and we can check off a few more of these. And we can go ahead and release these. And you notice that as I'm selecting these, a number of other features come up here. There's things that we can do around priorities. There's a new enhancement that's coming that would allow you to split work orders and do some more massaging on the orders themselves. You can lock some things. You can create groupings and other factors like that. I'm not going to go through those in the demo today because we really don't have time for that. But it gives us quite a bit of flexibility to massage the schedule. And we're going to go ahead and release those now. And they'll now be reflected as we look at our resource load graphs, system load graphs, and functions like that. So you've got the ability as well to create a number of different views. Let's say you've got 3 value streams within the plant that are kind of discrete scheduling areas. Each of the planners can be, or schedulers can be working their own space independent of the other scheduler. So you can create different views and save those. So you've got quite a bit of flexibility around how you work in the scheduling environment. Once we've got our schedule established now and we've released some material, we can go out and look at our system load graph. This is really important because it gives us a tops-down view of all of the loading of all of the resources. We're looking out right now at the next week. We can look out at different time horizons. We can isolate just our constraints, our buffered resources, our free resources, as we call them, that are being infinitely scheduled. Down below, you can see the loading, and they're sorted kind of high to low here in terms of which resources have the most loading. C2 is a constraint. You can see because it's got the blue badge there. It's got most of the workload for the next week already released. That's what the blue bar represents as a portion of this total bar. And then you can see our C1 constraint comes right after that. You can have categories of resources, so you've got quite a bit of flexibility. I mean, some of the plants that are out there have literally, hundreds of machines and things like that. So this gives us a way to have a very good tops-down view of, how do we look from a loading relative to the amount of capacity that we've got out in the shop environment. As we go to the resource load graph, now we're going to drill down and look at the resource load graph for a given resource, in this case, the C1 constraint. And as we update that now for the additional workload that we release, we can see what the schedule looks like over the next really couple weeks. There's a fair bit of work that's already been released. It's on its way to that drum resource. Obviously, there's some workload that was released today that's not going to get to the drum resource until early part of next week. Hopefully, you can see that as we hover over each of the days, we get an understanding of the available capacity, how much has been unreleased and how much is already released. So it gives us good visualization of what our schedule looks like. If we had orders coming in that needed to go across the C1 resource, then we would say, hey, look, we've got capacity opening up around April 22nd and beyond. And so that's giving us an indication of what would our capacity tested due dates be for orders that might be transiting that constraint resource. And this is why I'm talked about earlier in the presentation that building this handshake between these two dimensions is really, really critical for us, because it's going to give us the ability to start to inform the DDMRP or the materials side of the house in a much, much better way in terms of what our promise dates can be for the various work orders that are out there. There is also then now the buffer board, and this is a critical part of, constraint-based scheduling. You can see we've got a number of work orders that have yet to be received at the C1 drum resource. As time passes, and if you saw it or noticed as I refresh the screen, these two orders move from left to right here one stage. These are the time zones within the buffer, green, yellow, and red, again, giving us a way to understand and alert priority as to the status of the orders. You have expediting. You have a buffer manager whose work on the shop floor is to help ensure that that drum resource is always going to have work to be performing. And they're going to be monitoring the buffer board to ensure they understand what's the status. And if, as time passes, and these these work orders that you're seeing here start to come late to the buffer, they're obviously going to be expediting, trying to understand, and then dealing with the operator at the drum resource because you may find that you're going to have to change the sequence of the orders you operate on because you're, again, trying to protect that constraint because of some upstream disruption that may have occurred. When we get to this, we can click on that work order itself, and we can indicate if it's been received. So let's receive this into the buffer board. And when we come back here now, you're going to see it's going to be moved from unreceived now into the received side. And if we then go take that work order and now we start it on the drum resource, what you'll see here when we come back to this is that it's going to disappear off there, because now that job is operating. Maybe I didn't finish that. Yep. So it should, it should disappear off the buffer board because it's no longer there. And I'm on a pre-release version, so that may be why we're still seeing it there. So my apologies for that. But this is how we get visibility. And as time goes by, these orders are going to continue to move across and indicate their status. And that's how we get better visibility and prioritization of our actions on the shop floor as we go through our workday. There's another thing I wanted to show here. This is a where is it? I've got so many different tabs open. So we have resource schedules. We can see the resource schedules for all the different resources in the environment. We can identify, if I'm looking at these are only going to be the released work orders that they're going to have visibility to. We don't want operators on the floor pulling work in before it's really needed to be working, because we're trying to control, again, through a choke and release kind of mindset, the flow of materials out onto the floor. So we're going to be managing that very, very closely. One last thing I wanted to do here before we stop and take a couple questions is I want to go to site administration here. And because there's some important functionality around this, we'll go to the processing area, and you can see we've got two areas for scheduling and execution priority. There's a number of parameters. Obviously, we have to align ourselves to the operating environment. Some plants will be looking at units per hour, others may be hours per unit. So there's a number of different ways we're going to be thinking about how we're utilizing time in that environment. And so you've got the ability to configure and tailor the settings for the location that you're operating around within the system from the standpoint of site administration. You also have this ability to turn on execution priority. When we first ran the scheduler, you saw that all the work orders had the same priority. I can actually change this and enable execution priority. And the benefit in doing this is that now it's going to look across to the materials planning side, understand the status of the buffers or the non-buffered work orders, and be able to do a better job of prioritizing the schedule based on those elements. So you can see here, we've got whether or not we're going to be including order spikes, what kind of prioritization scheme do we have? So when we're looking at buffered parts, those that are stocked out are going to get the highest priority. The lower the number, the higher the priority, then critical, then red, yellow, and green. In this way, it's interpreting the status of those buffers. And if, like in make to stock environments, we're going to be, giving preference to those items that have the deepest buffer penetration. Because again, from a materials management standpoint, we're trying to ensure constant availability. We can have min-max parts as well as non-buffered parts. Non-buffered parts are your make-to-order items, right? And so here we can set that scheme so that we're protecting our buffer positions as well as interleaving the priorities from a scheduling standpoint in terms of the make-to-order environment in the same environment. So I'm going to go ahead and turn this setting on, and we're going to enable that. And what that's going to do then is allow us to reflect those priorities when we go back to the scheduler. So I'm going to go back now, and I'm going to rerun the scheduler. And you can see now that our priorities have changed. These were all values of 10. Now they've changed to reflect the various work order priorities based on the buffer status or the specific make-to-order status of the materials that were related to that work order. You also see an important function here around material availability checking. Now we know when we're doing scheduling, if we've got this feature enabled, whether or not the material is available. The last thing we want to do is be releasing work orders out onto the floor if we know that there are component availability issues on that work order. A lot of people will ignore these and they're just, pushing work out onto the floor, irregardless of whether all the components are there. We really want to avoid doing that because that's really just going to incur more of a challenge for us within the operating environment to be able to effectively manage. So I think I'm getting short on time here. It looks like a few questions have come in. So I'm going to stop the demo at this point and see what questions we've got. Okay, Corey says, for the execution side of things, which was DBR Plus, is there a UDF option to assign an employee to a job that is viewable from looking at all manufacturing orders? Saying one constraint, not everyone knew how to do everything, so they had to execute out of the plan priority. That next person could easily see whom. Yes, there are some work order UDF fields that could be utilized to support that kind of functionality. Next question. How many people in the scheduler, sorry, I'm jumping around, can be at the same time? Well, technically there's no reason that you couldn't have a number of people, a large number, but you have to be mindful of the fact that there is a lockout feature that if they're working in the same resource areas, they cannot be scheduling at the same time. So, we want to have multiple users be able to access the system, but we also have to respect that we can't be scheduling on the same resources from different angles. We've got to be able to do that in a more coordinated fashion. So my recommendation is that you really think about that in terms of value streams, work centers, and the like. And if you've got isolated areas or areas where the routings don't cross paths, then you can absolutely take advantage of that functionality. And a lot of clients that I've seen now have really migrated to kind of that value stream oriented layout where they've got some unique areas within the plant that are kind of independent, kind of plant within plant, if you know what I mean from that perspective. Yeah, on the material availability check, that would be a different way of looking at it, where we would only indicate where true is. We've had a suggestion to add some kind of a colorful indicator there as well. So we may make some enhancements on that side. But you can also filter on that column to true as well and only see the work orders that have material availability checks. And that will be a handy way to govern and manage that. Yes, Doug, the question about timestamps here, with Intuiflow, everything is location aware. So locations will have time zone definitions because we have to have that. We've got to know what time of day it is in your local context. Otherwise, if you had multiple plants in the same instance of software, it would not really understand the different location requirements. And so, yes, we do have the ability to have local timestamps, and that's a setting that you establish for the location in the Intuiflow software. Okay, I think I'm at the end of my allotted time, so I want to thank everybody for your participation. Hopefully you found this interesting and informative. Obviously, it was a bit of a speed run through the application, and we'd obviously like to spend more time with you if you're interested to go into more of a deep dive around the functionality of the scheduling engine function, scheduling and execution functionality in Intuiflow.